So let's solve this question. So first we will solve this question step by step. Limit x tends to pi by 2. 1 minus sin x power sin x whole divided by cos square x. So first of all, we will substitute the limit value. So 1 minus sin pi by 2 whole power sin pi by 2 divided by cos square pi by 2. So sin pi by 2, we know sin 90 is 1 whole power 1. Cos square 90 is 0 square. 1 minus 1 in the numerator is also indicates 0. So 0 by 0, which is undetermined form. So when we will have this answer, so our next approach to solve this question is L'Hospital's rule. So according to L'Hospital's rule, consider the problem again. So here you should learn some formulas. So the formulas are first one, we will concentrate on denominator, cos square x. How it will look like? It look like x square. Base is variable cos x and power is a number. So you can compare this problem with x square so that you got 2x. So in the same mode, you can write 2 cos x. But of course, it is not, the base is not x, it is cos x. So we will continue the differential procedure. So this procedure is called chain rule. Cos x derivative was minus sin x. So finally, we got minus of 2 sin x cos x. And from trigonometry, we know that 2 sin x cos x is sin 2x. So just write down sin 2x. If you see in the numerator is, you can see in the numerator 1, derivative of 1 is 0. And along with, you can see sin x power sin x. So here you can find that base is a variable and power is also variable. In such cases, we are using a different formula again, derivative of f of x power g of x. So derivative of f of x power g of x is f of x power g of x. We will write the same thing. And then g of x into f dash x means derivative of the base divided by f of x plus g dash of x into log f of x. So try to remember this formula. So here f of x is sin x and also g of x is sin x. So therefore the answer for this problem is sin x power sin x like f of x power g of x. G of x means sin x and in the denominator it's same function sin x and its a derivative will be in the numerator. Sin x derivative cos x, of course these two things got cancelled. And then plus g dash of x, sin x derivative cos x into log f of x. F of x means sin x. So now we will replace the terms with these derivatives because we are using L'Hospital's rule. First, take a look at the numerator. Once derivative was 0 and then minus. We already know how to differentiate this sin x power sin x. We already done that as a rough work. Sin x power sin x and cos x and then plus cos x into log sin x and whole divided by in the denominator minus sin 2x. Cos square x derivative minus sin 2x. Okay. Now you can take this cos x as a common factor from this bracket. And this minus minus you can cancel directly. So try to solve this problem now. So limit extends to pi by 2. Cos x was taken outside as a common factor, multiplied by sin x power sin x and 1 plus log sin x and whole divided by sin 2x. And we know how to solve this problem, present problem. And of course, again, we are getting 0 by 0. So for reducing that, what I am doing is I'm just multiplying with x and dividing with x. Multiplying with x and dividing with x. So here I am using the formula. Limit extends to some 0 or 90. Pi by 2 sin 2x. Sin 2x by x. Okay. Or leave that formula. We are not going to do this operation. And this operation is also I'm removing because it is not 0. It is pi by 2, right? So it needs one more time differentiation because if you substitute this limit in this stage, if you substitute this limit cos pi by 2 multiplied by sin pi by 2 whole power sin pi by 2 of 1 plus log sin pi by 2 whole divided by sin 2 times of pi by 2. So you can see this cos pi by 2 is 0. 0 of anything will be 0. So complete numerator will be 0. 2 got cancelled. Sin pi is also 0. So again we are getting 0 by 0. So I'm again ready to do this L'Hospital's rule. So again I am doing L'Hospital's rule. Limit extends to pi by 2. So here you can see three functions, 1, 2, and 3. Three functions differentiation. And if you see in the denominator, always we have to cross check in the denominator because this will make the problem so forwarding again to L'Hospital or not. Sin 2x derivative was cos 2x into 2. If you substitute this limit, 2 got cancelled. Cos 2 into pi by 2, 2 got cancelled. Cos pi is minus 1. So we are getting a finite value. So it is okay. Now you can proceed to do L'Hospital's rule in this step. Okay, in this way you can confirm that this is the last step or not. Now I am doing UVW rule. First I am doing U dash. I will write the formula. U dash VW plus UV dash W plus UVW dash. So here UV is cos x, where UV is cos x. V is sin x power sin x. And W is 1 plus log sin x. So U dash will be minus sin x. And V dash will be, we already done this, right? Sin x power sin x into cos x of 1 plus log sin x. And W dash is once derivative 0, log sin x derivative cos x by sin x, of course cot x. We will see what happens here. So limit x tends to pi by 2. 2 cos 2x in the denominator. U dash means minus sin x. V means sin x power sin x. And W means 1 plus log sin x. And then plus U means cos x. V dash means sin x power sin x into cos x into 1 plus log sin x plus, no, U, V dash was done, and W means 1 plus log. So I can make whole square. U, V, W dash. U means cos x. V means sin x power sin x. W dash means cos x by sin x. Now I am substituting 90 degrees in the entire problem. So as we calculated already, cos, so we will write it again, no problem. 2 cos 2 into pi by 2. In the numerator, sin 90 was 1 and 1 power 1 and bracket 1 plus log 1 because sin x is sin 90 was 1. And cos 90 is 0, the entire thing is 0, and the next entire thing is also 0. So minus 1 into 1 plus log 1 is 0, divided by 2 got cancelled. So 2 times of cos pi is minus 1. So minus 1 by minus 2. So therefore answer is 1 by 2. You can copy this solution. Understood? Option 3 is correct. First, we need to solve this f of x. Actually, it was given in the form of determinant. So let us finalize that. Cos x, f of x is equal to cos x, x and 1, 2 sin x, x square, 2x, tan x, x and 1. For solving this, we will use Sarah's method. In Sarah's method, we will repeat for any determinant. You can use this Sarah's method to solve. Only this is for objective examination, not for board examinations. So 2 sin x, x square, 2x. Write down same determinant, tan x, x and 1. Repeat the first two rows again. Cos x, x, 1, 2 sin x, x square, 2x. And make arrows from the corner. And be careful while you are assigning with the elements. Multiply all the numbers, what this arrow contains. So 1 into x square, x square, x square into cos x, x square cos x. And again draw one more arrow. Multiply these numbers. 1 into x, x into 2 sin x, 2x sin x. And again do multiplication with third arrow. 2x into x, 2x square into tan x. So 2x square tan x. Okay. And then do the same process with other corner. From the top corner, you have to make arrows. If you try to multiply, so x square into tan x, multiply all the numbers and draw one more arrow. So 2x square cos x and one more arrow. This is 2x sin x. Okay. So this was, you have to add these numbers. It is called a left sum because it was in the left side. So x square tan x plus 2x square cos x. I am adding all the numbers, 2x sin x. And this is what called right sum. Just add it all. X square cos x plus 2x sin x plus 2x square tan x. So actually f of x value will be right minus left. And you are thinking why this process, generally we know that how to solve the determinant. Of course, you can use the general determinant method also, no problem. By doing this method, you can do calculations within seconds. And the functions setup will be familiar. That means you can understand uh, the functionality. Look at that x square cos x. This is very looks like familiar, right? So f of x will be right minus left. Remember this rule, right minus left. Always determinant will be equal to right minus left. So right, you can see, take x square common because these two numbers are having x square. So the rule says right minus left. So write down cos x minus tan x. And the next x square also, here also we are having, right? X square, 2 cos x is also there. I closer the bracket, wait. So two terms we are having here with contains x square term. So here also. So cos x is first one, right minus left I am doing. Next 2 tan x, right side sum, minus left side sum. Left side sum is x square was taken, so tan x, again minus 2 cos x. And then plus, take x common. First we will write right side. Of course, these two got cancelled, right? So we are having the function f of x. Okay. So therefore, f of x is equal to x square of tan x minus 2 tan x minus tan x is tan x. Cos x minus 2 cos x is cos x. And if you do f dash, because the problem consists f dash x by x. So what we will do, we will use u into v rule because derivative, you know how to do that. X square of tan x derivative secant square x. So here I am mentioning u means x square, v means tan x minus cos x. And for u dash is 2x, and for v dash is tan x derivative secant square x minus cos x derivative plus sin x. So the formula was uv dash plus vu dash. uv dash plus vu dash. U means x square, v dash means secant square x plus sin x plus vu dash. V means tan x minus cos x and x square derivative u dash means 2x. You can take x common from the entire function. So x into secant square x plus sin x, x sin x plus 2 tan x, x was taken, minus 2 cos x. This x was moved to left side. So now it is f dash x by x equal to x secant square x plus x sin x plus 2 tan x minus 2 cos x. Now limit is approaching to 0. So limit x tends to 0. F dash x by x is equal to wherever x is, there substitute 0. 0 into sine 0 plus 2 tan 0 minus 2 cos 0. 0 into anything 0. Of course, secant 0 is 1 there. Both are zeros. This is also 0, but 2 into this is cos 0 is 1. So minus 2 will be the answer, this question.